Hi, welcome to Workplace Math 11, Module 4. This is Part 1, Simple and Compound Interest. The first thing to do is a couple of calculations, changing percents to decimals. This is an important basic skill for this unit, a necessary skill. All right, so 12, remember that percent literally means per 100. Think of cent. Pennies, cents, there's 100 cents in a dollar. There's a century is 100 years. So per cent means per 100. So this is 12.5 divided by 100. And you can use your calculator to get you 0.125. All right. So just pause the video right now, do these 4 calculations, and come back right away. All right. Let's make sure you've got those numbers right. If you're having trouble with this, please make sure you get some help before you go any further, okay? This video is actually, this lesson is a whole bunch of really short little mini lessons and then some practice work. So I really recommend that you don't watch the whole video through in one go. Pause it every time I'm telling you to pause it. Do the couple of practice questions that are there. Sometimes there's more than a few, but do the practice questions before you go on to the next section. All right? Okay, Part B, an introduction to interest and investments. Interest is an amount of money paid or charged for when you deposit or borrow money. What does investing mean? When you take some of your money, taking some of your money and lending it to a person or a company so they can use it to help them make money. They will give you a small cut of the money they make. What are some ways to invest your money? Bank accounts. When you have your money sitting in a bank account, you are actually lending that money to the bank. The money doesn't actually sit in your bank account. They take that money and they lend it out to somebody else at a higher rate of interest. The money just goes round and round and round. You can also invest your money in stocks. When you buy shares in a company. And there's private lending. When you lend money to someone you know. There are other ways as well. How do these ways differ? Usually, the more risk that is involved, the higher the interest that you can earn. If things work out, sometimes you don't get anything if it's a really risky investment. Bank accounts are non-risky. We're going to start with the simple interest. There's 2 kinds of interest, simple and compound, and we're going to do some work on simple interest first. So simple interest is interest paid only on the initial amount deposited or the amount borrowed. The initial amount deposited is called the principal. Time is the number of years over which the money is deposited or borrowed. And interest rate is the percentage of interest that you accumulate every year. Make sure that you change your percent to a decimal when you use the formula. The formula for simple interest is I equals P times R times T. So that translates to the I is the amount of interest earned or due. P is the principal amount, so the amount that was initially borrowed or loaned. R is the annual percentage of R is the annual interest rate. expressed as a decimal, and T is the time of the investment in years. The formula for the total value of the investment at the end of the year is A equals P plus I, where A is the total final value, P is the principal, and I is the amount of interest earned or due. And that makes sense because what you owe, if you've borrowed the money at the end of the 2 years or whatever, you owe all of the interest plus you owe the original amount of money that you borrowed. Converting time to years. Sometimes money is invested for less than a year or parts of a year, for example, 2 years and 7 months. How do you figure out the time T, which is measured in years for these instances? Well, you need to know that 1 year is 12 months, 1 year is 52 weeks, and 1 year is 365 days. So use fractions, all right? So for example, 11 months would be 11 over 12 because there are 12 months in a year and you've done 11 of those months. Okay, so pause for a moment and do these conversions, these 4, and we'll check them together and then you can come back to the video. Okay, 5 months is 5 over 12, 5/12ths of a year. 42 weeks is 42 52nds of a year. And you can reduce that, but you're just going to multiply it by something, so I wouldn't worry about that. 1 year and 23 days. Well, we want it as a fraction of a year, so that's going to be 365 days. And on the top, we're going to have 365, which is the 1 year plus 23. So that's how much of a year we have. And if you add that up, that becomes 388 365ths of a year. 4 years and 2 months, well, we're talking months, so it's going to be out of 12. And 4 years is 48 months plus 2 months, so that's going to be 50 over 12. Okay? All right, example of calculating simple interest. For example, you would like to invest $15,000 in an account that offers simple interest. Calculate 1, how much interest would be earned, and 2, how much the final investment would be worth if the investment was for 38 months at 6.70%. So, part 1, interest. We're asked to calculate interest, so it's I equals P times R times T. Principal is the initial amount invested, so that's $15,000 times the rate, 6.7%, but as a decimal, 6.70% equals 6.7 divided by 100 equals 0.067. So that's our rate, 0.067. And 38 months, so that's 38 over 12. And then we're just going to calculate that. We get I equals, we just put that in the calculator and multiply it all together. That's 3,182.50. You're always going to round to 2 decimal places in this section because we're talking about money. And part 2 is A equals P plus I. So the principal was 15,000 plus the interest, which was 3182.50, and that equals 18182.50. So there's our second answer. Oh, dollars, I should put my dollar sign there. And here's our first answer, part 1. Okay? All right, go and do the practice, and I will meet you on page 6. Okay, the basic interest formula, the simple interest formula, can be manipulated to find different values. There's a formula if you want to find the principal, there's a formula if you want to find the rate, and there's a formula when you want to find the time. So for the next couple of questions, it's just about finding which equation you should use for whatever you're wanting to find. In this example, Jeff made $72 in interest. So the way I would do this is I would go, well, I would write down what I'm given. So I know that the interest is $72. The principal amount he invested was $900, and the time was 2 years. And we're looking for the rate, the interest rate. That's what we're asked to find. So we're going to use this middle formula up here, where R equals I divided by P times T. So it equals 72 divided by 900 times 2. My calculator will tell me that that is 0.04. Make sure you're getting that on your calculator. You can't just punch in 72 divided by 900 times 2. That won't work. You either need to go, what you would do is go 72 divided by bracket 900 divided by 2. Okay, that will work. Anyway, the answer you're going to get is 0.04, but you need to change that back to a percent. That's the decimal version. So your answer is actually going to be 4%. Okay, and you get that by multiplying it by 100. So let's do that. So that's times 100 to get you that. Okay, so do the practice questions and I will meet you on page 8. So now we're going to talk about compound interest. The reality is that simple interest doesn't exist much in the real world. Pretty much only if grandma lends you money are you going to pay simple interest. Anything you do that involves a bank is going to be compound interest. So we're going to spend some time looking at the compound interest formula, which is not surprisingly more complicated. But that's okay. You can handle it. I want you to do these first 4 practice questions and check your answers right now if you haven't already done them. So if you haven't done them, pause the video and do them and then come back and check. Okay, those are the answers. They're rounded, other than the first 2. What is important when you're doing this is that you make sure you put the brackets in where the brackets are in the equation, and to use the exponent button on your calculator, it can look like any of these. If you're having trouble with that, contact your teacher before you go any further to make sure that you've got clarification on how to use your calculator. Okay. Going on then, simple interest is interest, you earn interest only on the starting principal. Year after year. Compound interest is interest you earn each year. The interest you earn each year is added to the principal. And this becomes your principal for next year, which is great if you're lending money and not so great if you're borrowing it. For example, say you invest $200 at 10% per year. After 1 year, you earn $20 in interest, and you now have $220. And then for the second year, your new principal amount is that $220 instead of just the 200. So your interest on year 2 is 10% of 220, which is $22 rather than just $20. In the third year, your new principal is $242 because you're taking this $22 that was the interest for the second year and adding it to the principal for that year to get you 242. And that continues on year after year. Let's look at the formula and see how that works. First, we're going to look at calculating compound interest with annual compounding periods. That means that the interest is added on once a year. The formula is A equals P times 1 plus I to the power of T, where A is the total amount of money you have after the interest is added, P is the principal, I this time is the interest rate as a decimal, instead of R. Before it was R was the interest rate, now it's I, and T is the number of years the money is invested. So for example, Evelyn interests $10,000, so that's the P is $10,000 for 3 years, so time is 3 years at 5%, so the interest 5%, which needs to be written as a decimal, so that's 0.05. And we are looking for the amount that she's going to have at the end of that time period. So amount is P times 1 plus I to the T. So that's 10,000 times 1 plus 0.05 to the power of 3. So I put that in my calculator. I get $11,576.25. And again, remember, you're going to round that to 2 decimal places. Okay? Go do the practice, and I will see you on page 13. Okay, we're back again. Did you do the calculation numbers on page 12? Make sure that you've done those calculations on page 12 and you got them right. If you didn't, make sure you're asking for help, okay? All right, the interest percentages that we've seen so far have all been compounded annually, meaning once per year. However, interest can be compounded with various frequencies, as seen in the table below. So it can be compounded annually, which means once a year, semi-annually, twice a year, quarterly is 4 times a year, monthly 12 times a year, weekly or daily. If the compounding period is not annual, then we need to modify the compound interest formula, where A is still the total amount of money after interest, P is still the principal, I is the interest rate as a decimal, but this time it's I over N, and because we're dividing it by how many compounding periods there are in a year. And then the exponent is number of years times the number of compounding periods in the year. We'll do an example so that will help this, okay? Ross invests $8,500. Let's write out all our formulas or all our variables again. So he invests $8,500. That's our principal. Time is 3 years. The interest rate is 5.2%, which is 0.052 when we write it as a decimal, compounded monthly. So N is going to be 12 because it's compounded 12 times each year, and we're looking for the amount after 3 years. So the amount is the principal times 1 plus I over N to the power of NT. Okay, so the principal is 8,500. 1 plus 0.052 divided by 12 to the power of 12 times 3. Okay? Now put that in your calculator. You're going to need a bunch of brackets for this, okay? You're going to need to go 8500 times bracket 1 plus 0.052 divided by 12 bracket to the power of, which is, you know, your little hat button or your y to the x or x to the y. And then make sure that you do the 12 times 3 with brackets around it, okay? And the answer that you should get is $9,931.67. Okay, so make sure you check that, and then make sure that the number that you're coming up with makes sense. It's got to be bigger than 8,500. Okay, that's one thing. If you make a mistake when you're typing up your calculation, or you're putting it in your calculator, make sure that you're getting an answer that makes sense. Okay. All right, next example. If you're investing money, do you think more compounding periods or less compounding periods will make you more money? Why? You thinking about it? The more compounding periods you have, the more money you're going to get or pay, because you're paying interest on interest sooner. Okay? All right, go do the practice, and I know I haven't been saying this, but I'm assuming you're checking your answers and doing your corrections as you go, and come back, and I'll meet you on page 19. Oh, sorry, page 17. I'll meet you on page 17. Okay, we have another version of the compound interest formula. This is just the same equation manipulated to let you find the principal. It's a little more complicated to plug into your calculator, but if you do the thing we've been doing where you write out all of the numbers as you find them in your question, it's not much more difficult, okay? So Aiden made an investment, and after 3 years, so our time is 3 years, of 4% compounded annually, so our interest is 4%, which is 0.04 as a decimal. He had a total, so that's the amount, is 688.45. How much did he originally invest? Oh, compounded annually. That means that our N is 1 because it was compounded one time a year. Okay, so principal equals the amount divided by bracket 1 plus I over N to the N times T. So that is 688.45 divided by 1 plus 0.04 divided by 1 to the power of 3 times, or 1 times 3, 3 times 1. Okay? And that gets us an answer of $612.03. Does that make sense? It should be less than what he ended up with, right? Because he's making interest on this amount. Yeah, that's okay. That's a reasonable amount. Okay? All right. Go do the practice, and I will see you on page 19. Okay, there's this thing called the rule of 72, which is an approximate number for how long it will take for an investment to double. Sometimes investors would like to know how long it takes to double their money. There's a neat way to do this called the rule of 72. It only works for something that is compounded annually. And the rule of 72 is 72 divided by the interest rate as a percent. That gives you the doubling time in years. Example, suppose you have an annual interest rate of 3.8% per year for an investment of $4,000. How long will it take this to double? 72 divided by 3.8. Notice that this time we're leaving it as a percent, not a decimal, and the answer is 18.9 years. All right, go do the practice. I'll see you on page 21. That's our last section, page 21. Last example. If you wanted to double your money in 15 years, what rate of interest would you need to invest your money at? So we had time equals 72 divided by the percent. So if we want to know the percent, that's going to equal 72 divided by time. So if we want to double our money in 15 years, then 72 divided by 15 equals 4.8%. So you'd need to find an investment at 4.8%. The way I did this conversion is I set this up as a proportion, and I used the cross multiply and divide so that my percent equals 1 times 72 divided by time. Right? Multiply the pair, divide by the spare. Okay? All right, that is the end of the lesson for this part. Go do the practice, do your corrections, write the quiz, and I will see you in the next video. Bye.